Welcome to the partial screen shake shader tutorial by PeerPlay. In this tutorial I will teach you how to create an alternative way to implement the screen shake effect in Unity using Shadergraph and C#. In this first part I will visually explain the concept of screen shake and show the features of the shader that we will create. For those of you who are new to my channel, I'm a technical artist and create tutorials about audio visualization, algorithms and shaders using Unity Engine. Creating these free tutorials takes a lot of time and effort, and I couldn't have created these without the support of all the amazing patrons at my Patreon. If you find the contents of my tutorials helpful, consider supporting me at Patreon. In doing so, you not only support me creating these, but you get access to the source files and extra content. Special thanks to WayneGlows. Check out the link to his awesome SoundCloud in the description. So, what is a screen shake? A screen shake is an effect to mimic the physical impact of an explosion or an earthquake. In a first-person camera setup, it can also mimic the player that has been hit. It creates a more chaotic experience to the player. It was first introduced in two-dimensional games, in which the camera position is displaced in a random X and Y position. In this third-person setup, that would look like this. You can do this following this snippet of code. The position of the camera is offset randomly on its axis, while the shake power decreases over time. Let's analyze the characteristics of this approach in a third-person camera setup. The effect is noticeable on the objects that are near the camera. It's unpleasant to look at the character during the shakes and notice that the mountains in the distance barely move. A better way of implementing a screen shake in 3D is by rotating the angle of the camera. You can do this by following this snippet of code. Notice that it's now more pleasant to look at the character. Here we can see the inverted effect where the objects that are far away move more than that which is close to the camera. Instead of moving the camera, we are going to create a post-process effect by offsetting the pixels of the camera. As we can be sure that the player will be mostly focused on the character, we don't want to shake the area around the character. This is what the result of the partial screen shake shader looks like. Notice that all the pixels around the player stay perfectly in its place. How do we achieve this? We will create a tracking system of the character's position and make sure to keep the character within the frame as it moves around. We will draw the frame as you see it using the same shader we use for the screen shake effect, so we can use it to debug and test our settings. The width of the border around the frame indicates the smoothness of increase of intensity from the center to the outside of the screen. Let's have a look at some different presets. Here's a screen shake with a range of 40 meters. Notice that the border is thick, meaning a smooth transition, and all the pixels within the region remain unaffected. Here's a shake at twice the intensity and twice the distance. Or the same shake at infinite distance. Or a very short shake. Or a slower, smoother shake calculated by noise instead of random. We can also choose to just shake the camera horizontally or just vertically. We will use the camera depth buffer to dynamically indicate at which range the screen shake takes effect. Now I will show you how to set up your project to follow along with this tutorial. You need Unity Editor version 2021 or higher. Create a new project using the 3D URP template. To make the post-process shader work, we need to set up a render feature and a volume component. I've created a template that you can download for free, so we can immediately start working on the shader. You can find the link to download the template in the description of this video. Place the files in the assets folder of your project. Add the template renderer feature to the high fidelity renderer. Add the template volume override to the global volume of the scene. By adjusting the intensity slider, you can test if the shader works. To follow along, you also need the Naughty character third-person controller. I'm not sure why she's called Naughty, she looks pretty nice to me. You can find the link to the GitHub page in the description of this video. Click on the green button and download zip. Unzip the file and drag and drop only the folder Naughty character into the project. Now go to Window, Package Manager, select Unity Registry and search for input. Install this package. The character controller uses this new input system. Now add a terrain to the scene, draw some hills, and drag the alien character into the scene. Add the camera rig, and add the player input prefab. And delete the main camera. Now we can walk around in the scene. That's it for the introduction to this tutorial. Thank you for following so far, and I'll see you in the next part. To stay updated with new content, subscribe to the channel and turn the notifications on. Happy coding!